Dear students, in chapter 1b, after studying the derivations of electric field intensity on axial line of dipole and second electric field intensity on axial line of dipole and then electric field intensity on a point on any line of a short dipole, the fourth topic I am going to discuss with you is torque on dipole which is placed in uniform electric field. So for understanding it, let us consider first uniform electric field. I am representing it by green color. This is our uniform electric field which is represented by parallel equidistant lines. This is your electric field E, which is a vector quantity and having direction this. Now let us consider a dipole in this. So let us say this is my dipole which is placed in electric field. This is positive charge and this is negative charge. Each charge has magnitude Q. Now as placed in electric field, positive charge will experience force in the direction of electric field and the magnitude of force is going to be F is equal to QE in this direction, while the negative charge will experience a force in this direction having same magnitude F is equal to QE. However, their directions will be different. The force on negative charge will be opposite to the direction of electric field and force on positive charge will be in the direction of electric field. Let the length of this dipole be 2a from the center, and this dipole is making angle theta with the electric field. If this dipole is making angle theta with the electric field, then it means that this line will also be making angle theta with the electric field, and we can consider a right angle triangle here. We can name it A, B and C. Now you know that for the formula of torque is either force into perpendicular distance. Here the perpendicular distance between the forces is CB. This CB distance is the perpendicular distance which I have shown in red color. So the formula of torque, you must remember it. We have studied its derivation in class 11th, that torque is equal to force into perpendicular distance. You must remember this formula, and putting back the values in this formula, torque is equal to the value of force is QE and multiply by perpendicular distance, that is CB in our case. Now look at the diagram more closely. What is the value of CB in terms of 2A? We all know that base by hypotenuse is sine theta and base by hypotenuse is cos theta and perpendicular by hypotenuse is sine theta. So here CB is the perpendicular, and perpendicular divided by hypotenuse will give us sine theta. So CB by 2A is sine theta. Using this, we know that CB divided by 2A is equal to sine theta, and hence the value of CB can be written as 2A sine theta, and we can put this value of 2A sine theta in place of CB in this equation, and what we'll get out of this equation I can rewrite here. I can rewrite torque is equal to QE, that is the force, and multiply by 2A sine theta. Now one more small step here, I can also write it like torque is equal to Q into 2A. Q into 2A को मैं पहले लिख सकता हूँ और इंटू में E और फिर साइन थीटा. अब आप देखो यहाँ पे Q इंटू 2A तो हमारा डाइपोल मोमेंट का फार्मूला है, तो हमारे पास आ गया टॉर्क इज इक्वल टू पी ई साइन थीटा, where q into 2a is equal to p. Okay, one more step. If I want to, this is your equation for the magnitude of the torque, and if you want to write it in vector form, let me change the color for it. Okay, let us write it with green. So for writing it in vector form, you can write it like torque vector is equal to p cross e, and we all know that a cross b is ab sine theta, so p cross e is going to be pe sine theta. So this is your relation for torque in vector form. And what is the direction of torque? That is also one more important thing. So as you can see in this diagram, the direction of p is from a to b, because it's always from negative to positive. So I'll show you here all the colors I have already been used. So this is the direction of p. Direction of dipole moment is always from negative to positive, and this is the direction of E, which I have shown in green color. So in terms of P and E, let me explain you. Okay, first in this diagram you can see this is the direction of P and this is the direction of E. This is the direction of P, this is the direction of E. So the direction of torque is P cross E. So if you imagine a screw, if you will place it at the center and you rotate it clockwise, it will go into the paper. So the direction of torque here is perpendicular into the plane of paper. And similarly, if you are having an arrangement like this, that this is the direction of P and this is the direction of E, suppose in some case, and you want to find the direction of P cross E. Now as you are moving from P to E, for finding the direction of P cross E, you are moving in anti-clockwise manner. This manner is anti-clockwise. तो anti-clockwise, if you will imagine a screw here, it will come up. You are opening it, आप उसको खोल रहे हो, तो जो डायरेक्शन होगी टॉर्क की वो हो जाएगी परपेंडिकुलर अपवर्ड आउट ऑफ द प्लेन ऑफ पेपर. ये प्लेन ऑफ पेपर में नहीं है एरो, ये आउट ऑफ द प्लेन ऑफ पेपर है. मैं इसको अलग रंग से, आई कैन ड्रॉ इट विद अलग डिफरेंट कलर. So this is your perpendicular outward from the plane of paper, comparing to in this case when the direction must be going perpendicular into the plane of paper. Okay, so this is all about your torque on a dipole in uniform magnetic field. One more point I would like to add before finishing this topic, that net force on dipole which is placed in uniform magnetic field is always zero. About stable and unstable equilibrium we will discuss in next lecture. Okay, thank you.